Hi everyone, welcome to this video on units and unit conversion, more commonly known as dimensional analysis in a lot of classes. If you're taking a science class such as biology, chemistry, physics, math, for example, you will see units everywhere, and they are very important to get their final answer. So more specifically, for examples, you may see numbers along with a descriptor, such as 9 inches, 10 seconds, or 2 meters per second. The units are the descriptors that follow these numbers, such as like inches, seconds, or meters per second. Now, let's say these measurements, for example, which all are measuring different types of things, such as distance, or time, or speed, let's say we wanted them to be in a different unit, such as converting 9 inches into some amount of centimeters, 10 seconds into how many hours, and 2 meters per second into some amount of speed in, let's say, miles per hour, which is very common in the imperial system. This is known as unit conversion, or again, more commonly known as dimensional analysis. Here is a very simple example of how we do dimensional analysis in our everyday life. Let's say you get asked the question, how many yards are there in 3 feet? And intuitively, we know the answer that 1 yard is equivalent to 3 feet, or there are 3 feet in 1 yard. And so the answer to this question is just 1 yard. But what was the mathematical process that we really done in our heads in order to get the final answer? How many feet are there in 21 yards? So we know there is 21 yards. Now we intuitively need to think about how many feet there are. If you can't do that math in your head, or you're not used to doing this big of a conversion, this is where we're going to introduce a process known as the fence method. This is what I'm coining the term as. There's probably other names that you may have learned in any of your science courses. But this fence method is a way of keeping track of our units and being able to cancel out where we're able to. And the idea of this method is that it is essentially a fraction with just a bit more organization. Where in this method, we want our final answer to be in feet. So we need to manipulate our units in order to cancel out yards and keep feet as our final unit. Just like in any fraction, whatever is on top and on the bottom at the same time, for example here are 3, they can be canceled out, and your final answer here would just be 1. It's the same thing with our units. Whenever we have yards divided by yards, we'll be left with 1 as a final answer, or they would be canceled out. Now you may be asking, how can we cancel out yards when we're only given that there's 21 yards in our information? Well, as we know from the previous problem, we know the conversion from feet to yards, where 1 yard is equivalent to 3 feet. Another common way of writing this is that there is 3 feet per yard, where this per is also the same thing as this division sign, or there is 1 yard per 3 feet. These things are both equivalent, so either way, you can use either one of these fractions in order to cancel out our yards. So, the way that I like to approach this problem is we know the final answer we want it to be in feet, so let's use the information given to us that has feet in our answer or information, and let's put that on top at the beginning, where there are 3 feet for every 1 yard. Now we know we'll end up with feet on top as long as we cancel out yards. And the way to cancel out yards is to use the other information given to us, where there is 21 yards. And so within this problem, anything on the top and the bottom of this big fence can be canceled out, such as yards, for example. And the way that this adds up, just like a fraction, or multiplies as a fraction, is that you multiply the top divided by multiply everything on the bottom. Where anytime you write information in like 21 yards is just an implicit 1, not a 0 or anything. So you would just multiply the bottom by 1 times 1. So your total number would end up being 63 feet. So there are 63 feet and 21 yards. Now that was a very long explanation of how to go through this method. We'll be much quicker with the next practice problems. But essentially the idea is to cancel out units that you don't want and be left with the unit that you do want. For our next problem here, a boulder weighs 315 kilograms. What is the mass of the boulder in grams? Well, we're given a conversion factor of 1 kilogram is equal to 1,000 grams. So let's write out all the information that we have in any fractional form, where we have 315 kilograms as our measurement of sorts, and then our conversion factor is that there is 1 kilogram per 1,000 grams. Or I could use it the other way around, where there is 1,000 grams per 1 kilogram. In future problems, I'm not going to write both of them out. I'm just going to write one of them, and you can flip it either direction for whatever way you need to cancel out your unit that you need to. So if we set up our fence table, here, and we want our final answer to be in grams. So the information that has grams in our information is actually our conversion factor, where there's 1,000 grams for every 1 kilogram. And so we actually used the conversion factor that we needed. So we didn't need the left one, we only needed to use the right one. Now, in order to get our final answer, we need to cancel out kilograms, which is where we use the information that we were given, about 315 kilograms. So the final answer is going to be 315 times 1,000, or 315,000 grams. For our last problem here, the average person can walk a mile in about 0.33 hours. How long is this in seconds? So let's write out all the information that we're given. So we're given that there is 0.33 hours for every mile. Here, we're just going to say 0.33 hours because we're just really converting time from hours to seconds. Now, off the top of your head, do you know how many seconds there are in 1 hour? I do not. So the way that you can actually go through this is that you can actually convert it to an intermediate unit. You can convert it into minutes, and you can convert it into seconds from there. So there may be even more lines to that fence than just those 2 columns. So if we go through that process, we know that 1 hour has 60 minutes. And instead of writing in the fraction form, I'm just going to write it as they're equal to each other. And we know that there is 1 minute in 60 seconds. So this is actually all the information that we need in order to cancel out hours and minutes to get the seconds. Now at this point, we can set up our fence table. And here, we want seconds to be our final unit, as we are trying to find how long is this in seconds. And so I'm going to use the conversion factor with seconds and put 60 seconds on top and 1 minute on the bottom, because this is how we use our conversion factors. And now to cancel out minutes, because we don't want minutes anymore, 60 minutes is equivalent to 1 hour. And it's as simple as basically rearranging our units so we cancel out what we don't want and what we do want, and retaining what we do want. And so 0.33 hours needs to be put on top at the end in order to cancel out hours here on the bottom. And so we're left with our final units of seconds. And so the final answer is just going to be 60 times 60 times 0.33 divided by 1 times 1 times 1, which is the same thing as saying 1,188 seconds. And if you're in rounding for sig figs or significant figures in this case, it will be around 1,200 seconds, which is around 1/3 of an hour. Thank you all for watching, and I hope you have a good day.